Hi, this is Gordon Parker from Michigan Tech. Now, if you've seen some of the other videos that I've posted on this site, you've noticed that the focus of my research and teaching is control systems, usually with the help of a Simulink simulation or two. Not too long ago, I posted some videos where I used a Simulink toolbox called SimScape MultiBody. For those of you who have used SimMechanics Generation 2 in the past, MathWorkds renamed SimMechanics to MultiBody 1 or 2 versions ago. They're just different versions of the same thing, but with newer capabilities in newer versions. Now in those examples, I used the built-in drawing capability of the solid block for creating the model's 3D bodies. But there's another approach that my students and I use in my lab that has a bit more pizzazz, namely creating an assembly in SolidWorks and then using a MATLAB add-on to convert the SolidWorks assembly to a SimScape model automatically. This is a truly powerful workflow, since it's quite typical to use a solid modeling package to design some complex system while or maybe prior to doing dynamic analysis and control design. Porting a complicated SolidWorks assembly to SimScape lets you investigate its dynamic behaviors and perform that closed-loop control design. But best of all, you don't need to create the SimScape model. It's done for you. You can also embed these auto-generated models into real-time simulators if that's something that you like to do. It's certainly something that I like to do. So this is the first of several videos that are going to walk you through this process, all the way from setting up the connection between SolidWorks and SimScape to illustrating how to avoid pitfalls that can arise based on the approach that you've used in creating your SolidWorks model. In short, there are definitely some habits to avoid in creating your SolidWorks model if you want to generate relatively clean SimScape models. If I have time, we'll do a little bit of control design with a SolidWorks generated model at the end of the video series. That would just be a little extra fun. 2 students who work in my lab, Maya Hawthorne and Jacob Colling, will take the lead on these videos. I may pop in from time to time just to show you the connection between the auto-generated SimScape models and hand-calculated differential equation-based models. The point of that extra step is just to build up a little confidence that the auto-generated models are indeed correct. One last point. Due to some recent changes in our versions of MATLAB and SolidWorks, we'll start the series in this video using MATLAB 2015A and SolidWorks 2015. After this first video, we'll switch to MATLAB 2016A and SolidWorks 2016/17. The installation process for the add-on that hooks SolidWorks to SimScape is exactly the same for both versions, and that's probably the most important thing that you want to take note of. As I mentioned a minute ago, some of the terminology has changed. For example, SimMechanics versus MultiBody, so also keep an eye out for that. Another recent change in the SolidWorks to SimScape conversion process is how SimScape parameters are changed, but those are not topics for today. So, sorry for the long-winded introduction, but I felt it truly necessary. Now, it's my distinct pleasure to turn this over to Jacob for this first video on installation and sample model creation. Enjoy.
Hi, this is Jacob Colling with Michigan Technological University. Today, we're going to be porting SolidWorks models into SimMechanics. So in order to do this, the first thing we need to do is we need to download a SolidWorks plugin that will allow us to connect the 2 pieces of software. So first thing we do, we follow this link here, and we go to the MathWorks website, where we will be greeted by this page here, the SimMechanics link, and we'll need to enter some contact information, and then we'll be brought to this page here with all of our download links. So as we look through here, there are various download links. We need to download the correct one for the version of MATLAB and the type of computer we are using. Today I'm using MATLAB 2015A, so I need to scroll down right here. And I'm on a 64-bit computer, so I need to download these files here. Now, once we've downloaded these files, we want to put them in a folder where we can easily find them. And then we need to go to MATLAB now. So we need to open up MATLAB as administrator because we're going to be installing some things. And the first thing we want to do is we want to add a file to the path. So wherever you save those files you just downloaded, you want to add that folder to the path. So as you can see here, I have the files I downloaded in this folder, so I can access them now in MATLAB. So now to install the add-on, we need to type this command in MATLAB. And we need to, in the quotations, we need to put the name of the zip file we just downloaded. Just like that. So for my version, you can see the name we put in the quotes is the same as the zip file we downloaded. If we were using a different version of MATLAB or a different type of computer, this name would be different. So use the name for the zip file that you have. So do this right here. All right. Now the next thing we need to do is we need to register MATLAB as an automation server. So in order to do this, there's a command we need to type in. And we just gotta wait for this to all work through all that. Takes a little while. And as soon as that's done, perfect. Okay, so now as soon as that's done, we need to type in this command. And again, this will only work if you're running MATLAB as administrator. Reg MATLAB server. What this does is this registers MATLAB as an automation server, which allows us to connect the two pieces of software. All right, we're all set with that. Now, the last thing we need to do is we need to enable the SimScape MultiBody link plugin. This is the final step that connects these two pieces of software. So to do this, we type in this command here, SMLink SW, and we get a little pop-up here, and we should be all set. Now, to check to make sure we did this correctly, we need to open up SolidWorks. I'm using SolidWorks 2015 for this video. And what we do is we go up here to Tools, and we go down to Add-ins. This will show us all the add-ins currently downloaded and available for SolidWorks. And if we've done this correctly, you should see right down here under Other Add-ins, the SimMechanics link add-in. And this is what we just went through the process of installing and enabling. This allows us to export SolidWorks assemblies as .xml files, which SimMechanics can use. So click OK. All right, now that we have everything set up, we're going to model a simple pendulum here in SolidWorks, and then we're going to port it over to SimMechanics. So I'm just gonna make a new part here. Just let that load. And I'm just going to sketch on the front plane here, go normal to, select the sketch from the toolbar, and I'm just going to take the corner rectangle. Start at the origin and just make two rectangles to make a T shape. Click OK. Now, currently, my units, as you can see, are inches. That's fine for what I'm going to do today, but you are able to change this quite easily. If you go up here to the Options icon on the toolbar, we can go over to Document Properties and down to Units, and as you can see here, we have a couple different unit systems to select from. I'm currently going to stick with the inch, pound, second. OK. And we're just going to use some smart dimensions up here under the sketch toolbar. And we're just going to define this sketch we have just to make it look nice, and so we have exactly the dimensions we want. Oops, that's not what I wanted. These are just arbitrary dimensions. Really, the point of this video and what I'm doing here is just to show the porting process and how to set it up. And oops. And change that and add one more dimension right here. And we're all set. Now I'm going to click out of here, and I'm going to go to the features. Now in the features, whenever you make a part in SolidWorks, the most common way to make one is you start with a sketch on one of your planes, and then you make an extrusion to make your sketch three-dimensional. Now there are revolved extrusions, and there's a lot of more complex things you can do, but the simple extruded boss base is what I'm using for this, and this will just allow us to add depth to the sketch we just created. So I'm going to change, as you can see here, you can change the direction of the sketch, and you can change how you make your extrusion. So I'm just going to stick with that, and I'm going to edit the depth of the extrusion here, and I'm just going to make it 1 inch. As you can see, there's the yellow preview of what our part's going to look like after the extrusion. That looks good. Hit OK. And now we have a nice little simple T-pendulum. Now I'm going to add a hole to the top here, just so we can insert a shaft through it to make a simple assembly that will act as a pendulum. So I'm going to go normal to the front plane here, like that. And I'm going to sketch, click sketch, and I'm going to select this face to sketch on for my hole. So I'm going to go over here to line. I'm going to zoom in with the mouse wheel a little bit, and I'm going to draw a line from the edge to the midpoint up there, and then draw another one down. When you're drawing lines, makes it a lot easier if you want to draw lines at 90-degree angles to hold the shift key and then click. That will automatically keep the lines at the angle you'd like. I'm going to give this dimension here, and I'll make that 1/2 inch. Click OK. Now I'm going to go up here to the circle on the sketch toolbar, and I'm going to make a circle with the center point right at that point we just defined. Okay, and then dimension this off. I'll make that 1/2 inch as well. Okay, so now we've got our sketch for the hole we're going to cut. So now we can go over to the features toolbar, and we'll go right over here to the extruded cut. We'll click on our circle that we just sketched. As you can see, if you rotate around, you can see there's the yellow preview of where the cut's going to be. Like similar to the extruded boss base, we can flip the direction, we can do different things with how the cut is made, and we can change the depth of the cut. So I just want it through, so that's perfect. Click OK. And now we have a nice through hole in our part. So now this part is ready. So we're going to go up to File, and we're going to save it in a convenient place where we can find it again. We'll go to Documents, and I've got a file set aside for this. And I'm just going to save over this part here, because I don't need that part anymore. Okay, so we've got our first part of our small pendulum assembly made. Now we're going to go to File, and we're going to make another part. We're going to make a shaft for our pendulum to swing on. So we're going to go here. Shafts are very easy to model in SolidWorks, so I'm going to take about a minute. So we're going to go to our front plane, and we're going to sketch a simple circle. We'll dimension that circle to be 1/2 inch to fit into the hole that we made on the pendulum. Okay, and now we'll just make a simple extrusion. Let's make it 4 inches. So now we have a very simple shaft for our pendulum to swing on. And that looks good. And I'll go to save this part, and I'll save right here over that. Now we have both our shaft and our pendulum. Now to put these parts together, we need to make an assembly. So we're going to go up to File, and we could do New and make an assembly, but we're just going to make an assembly from the part right here. So now we've got an assembly. Now the first thing we need to do is we need to drop in a part to start our assembly. We're going to start with the first part that you drop into an assembly that's going to be fixed. And that will be the basis to build everything else around in your assembly. So it's important when choosing it's important to be careful when choosing the first part you want to use to start an assembly. Now with simple assemblies such as this, it's not terribly important, but especially when you get into more complex assemblies, it can make a big difference. So we're going to click and drag this part right here into our assembly. So as you can see, it's fixed, fully constrained, and everything else we add into this assembly is going to be built around this. So we're going to add our pendulum in now. And as you can see, our pendulum has full degrees of freedom. We can rotate it, we can move it, we can do anything we want with it. It's not constrained at all. So we want to constrain it so it'll actually act like a pendulum and be positioned on this shaft here. So we're going to go up to Mate, which allows us to position these components relative to each other. And we're going to click up here and here to make a concentric mate. As you can see, now this is effectively put the piece on the shaft, but it is able to both rotate and move along the shaft. In order to constrain this more, I'm still in the mates here, and I'm going to make a coincident mate with this face to the edge of our shaft. As you can see here, there are various types of mates you can do. SolidWorks will automatically suggest a mate type when you click two surfaces, two entities to mate. And most often that's the best to use. But I mean, for example, here we could make a distance mate. There's a couple different mates we could use, but I'm just going to stick with the coincident mate today. So click OK. Now, as you can see, our pendulum can only rotate around this axis. It cannot move along the shaft. It cannot move off of the shaft. Now, nice, simple, extremely simple model of a pendulum. Now that we have our SolidWorks assembly, we can now port it to SimMechanics using the SimMechanics link plugin that we just downloaded. So in order to do that, we need to go up here to Tools and then down to SimMechanics link. And we'll go over here to Export. Now in the Export menu, you have two options. You can export these models both into SimMechanics first generation and SimMechanics second generation. Now today, for this video, I'm going to be using SimMechanics second generation. So I go over to here, click OK, and now we need to choose a place to save our .xml file. This is the actual file that we will load into SimMechanics to give us our model. I'm just going to save over this file here. Okay, and now it'll take a little while, and it's going to generate a .xml file from the SolidWorks assembly that we just made. Okay, you should get a message like that telling you that you've successfully ported it. And now we're going to go back to MATLAB. Now in MATLAB, there's a specific command we need to use to take that .xml file and import it into SimMechanics. So the command, in order to use this command, we also need to have our file that we saved, our .xml file, that needs to be on our file path. As you can see, mine's already on the file path because I chose to save it in the folder that I already had the MATLAB path. But if you saved in another folder, you can simply go to the browse folder or add the path in any way so that you can access the .xml file you just created. So now to import the .xml file into SimMechanics, there's a specific command we need to use in MATLAB. And this command is sm import. So, single quote, and then we need to put the name of the file, of the .xml file we wish to import, which has to be on our file path in order to work. So we're going to type in example1.xml, end quote. And this will take our .xml file, and it's going to make a SimMechanics Simulink model from it. And as you can see, you should get a box like this pop up to tell you that the model is importing. And depending on how many pieces you have in your assembly and how complex it is, it can take a varying amount of time. So as you can see here, now we have a Simulink model of that assembly that we made in SolidWorks. As you can see, it's rather simple because we had a very simple assembly. And we can click on the Run button here to see our assembly in the Mechanics Explorer. And now, as you can see, we have a nice little pendulum here. It's modeled exactly the same as we had in SolidWorks. And if we run it here, we get a nice little pendulum motion. From here, we can edit things. If we wanted to edit the Simulink model, we could easily do that here and make all sorts of changes to our little pendulum that we modeled in SolidWorks. Now that's it for this video today. This was simply just to show you how to set up the link between SolidWorks and SimMechanics, and just what a simple port would look like. In later videos, we're going to get into more complex models and porting those over, as well as troubleshooting some of the issues that can occur when porting files with this process. I hope you've enjoyed. Again, the software I was using for this video was SolidWorks 2015 and MATLAB 2015A. The process is very similar, to my knowledge, with other versions of MATLAB and other versions of SolidWorks, but the most important thing about the version of the software you're using is the download. You need to make sure you download the right version of SimMechanics Link. Otherwise, this will not work. Well, that's all for today. Thank you. Have a great day.